And so like I said, it's something completely different that I never have done before. Well, I've done what we're doing, but I haven't done it with you guys. So so I wanted to make sure that you guys knew that this was being recorded before we did anything. So not that I'm discouraging you from asking questions or doing things like that, but I just wanted to make sure that you knew what was going on. So just to give you an idea of, let me do this, just to give you an idea of what is happening here. We just did percent composition, where we take a formula, and when we take a formula, the formula turns into a percentage. We can do that pretty straightforwardly. We find the molar mass, we find the parts. Yesterday we just did that experiment where we even measured it in and calculated it like in a real compound. So what we're going to do today is we're going to work our way backwards. We're going to start with percentages, and then we're going to find out what the formula is based on those percentages. So let me change my camera angle, and we will do a sample problem or two. Okay, so just double check that everything's set up. Okay, so here's what we got. Okay, let's say we have a compound that is 44.82% potassium, K is potassium, 18.39% sulfur, and 36.79% oxygen. Like, that's how this works, okay? And so what we can do is, given these percentages, we can go and find the formula. And we're going to do this using 3 steps, okay? We may need to do a 4th, but for now we're going to just do 3 steps, okay? And I will color code the steps, okay? The first step is to assume 100 grams, okay? So we do this to make the math a little easier. We do this to make the math a little easier. It's hard to do math with percentages. So by assuming 100 grams, if we do 44.82% of 100, that number is 44.82 grams. Okay, so it's just a way to convert the percentage to grams, okay, just by assuming 100 grams. So the first thing that we would do whenever we were given a percent is assume 100 grams. And that just takes the percentages and converts the unit basically from percents to grams. So 18.39% of 100, again, is 18.39 grams. And then, again, super straightforward, 36.79% of 100 is 36.79 grams. Okay, that's the first step. Now, the second step requires a periodic table. So what we're going to do is we're going to divide by the mass on the periodic table. Okay, so we have potassium here. We're going to take 44.82 grams and we're going to divide by the mass on the periodic table. So potassium is 39.0983. Okay, so let's do that math. Okay, so we have 44.82 divided by 39.0983. And when we do that, we get 1.146. Okay. We do the same thing with this, sulfur. Now, keep in mind that we can't use the same mass because all the elements have different masses. So we have sulfur, 32.066. So we do that math. Okay, 18.39 divided by 32.066, and we get 0.5735. Okay. And then the last one, oxygen. Yesterday, I had a student be like, oxygen, the mass of oxygen's easy. Okay, everybody can kind of knows it after you see it just a couple of times. So this is 36.79 divided by 15.9994. And again, we put that in the calculator, 36.79 divided by 15.9994. And that's 2.299. Okay, so that's the second thing that you need to do. The third thing, the third step, okay, is, and I'll do this one in blue, divide by the smallest. Okay, now that we have these three values, okay, we're going to look at the three and we're going to choose which one of these three is the smallest. Okay, so it's not, the good thing is that there's not anything kind of, groundbreaking with this. I'm not asking to, break out, what do I want to say? Don't want to break out square roots and squares and irrational numbers and all this stuff. Okay. You just find the mass in the periodic table. Then you look at these numbers that you just came up with and you divide by the smallest one. The smallest one in this case is this one, 0.5735. And you divide all of them by that. Okay. Now, by doing that, you will always get one value that's 1. And all the other values will always be above 1 because the smallest one is what you're dividing by. Okay. So now here we go. We're going to do the division. 1.146 divided by 0.5735. We get that. We get a value that's equal to 1.998. We get something like this. This, I will tell you, is close enough at this point to be considered 2. Okay, so we'll make that 2. Then we're going to do the same thing down here. We're going to do the division, 2.299 divided by 0.5735. And this, it says 4.0087, but I'm going to say that that's close enough to equal 4. Okay, so now look, we have whole numbers here. So what that is that tells you how many atoms of each element are in the compound. Look, so here we have 2 potassium, so we have K2. We have 1 sulfur, S. Remember, when it's a 1, we don't write the 1. And then we have O4 because we have a 4 here. So the formula for this is K2SO4. Okay, that makes it, so what I like about this is it's kind of like a puzzle, right? We have a puzzle and we have percentages that don't look like anything, but then we do just a couple of straightforward steps in math and we get a full formula that we can see right here. Okay, let's try another one of these. Here, let me move this one off to the side. Okay, so now here we have 52.0% zinc, 9.6% carbon, and 38.4% oxygen. Okay, so we're going to follow the same steps here as I have up here. We're going to assume 100 grams, divide by the mass on the periodic table, and divide by the smallest. And that should give us the formula for this. So that's step number 1 is to assume 100 grams. Okay. We assume 100 grams. So again, by doing that, that makes this convert super straightforwardly from a percentage to the unit grams. So it's 52.0 grams. 9.6% of 100 is 9.6 grams. 38.4% of 100 is 38.4 grams. Okay. So don't worry, Bastian. I normally would give people a shout out, but right now I'm doing something else. Okay, so then we divide the mass by the mass on the periodic table. Divide by the mass of the element on the periodic table. Okay, so zinc, we find zinc on the periodic table. It's right here, 65.38. So we're going to take this, and we're going to divide it by 65.38. Find carbon on the periodic table. Carbon's up here. Okay, it's 12.011. Okay, 38.4 divided by the mass of oxygen on the periodic table, 15.9994. Okay, so now let's do some math. Okay, 52.0 divided by 65.38. When we do that, we get 0.795. Okay, 9.6 divided by 12.011. We get 0.799. Okay, and 38.4 divided by 15.9994. When we do that, we get 2.40. Okay. So now we look, we say which one of these is the smallest. So we're going to divide by the smallest. Divide by the smallest. And the smallest is this one. So we're going to take this and divide by 0.795. Divide this one by 0.795. Divide this by 0.795. Okay, so this is going to equal 1. Remember, you're always going to have a 1 here. You're always going to have one value, one of these that equals 1 at this step. Okay, this one you can probably guess what it is. 0.799 divided by 0.795. This is also almost equal to 1. We'll keep it as 1. Then this one, 2.40 divided by 0.795. This is equal to 3. It says 0.019. Okay, so this again is just about equal to 3. Okay, it's close enough to 3 to equal 3. Okay, so now we can write the formula. That's the fun thing, right? We have one of these, and that's a zinc. So we have zinc, we have 1 carbon, and we have 3 oxygens. So it's ZnCO3. And that's what we get. Okay. Now I will say that you can have as many percentages as you want. Okay, so here's one with 4 percentages. It doesn't matter. You could have 7 percentages. The steps all stay the same. You assume 100 grams, you divide by the mass on the periodic table, and then divide by the smallest. Okay, and then eventually that's going to give you whole numbers over here, and then you're going to get a formula of N something, H something, S something, O something. Okay. The interesting thing, and why I love this, is because this is something that chemists do relatively often. This thing here is something that you can get a company to do. You can get these percentages pretty straightforwardly. You send it out. It's called elemental analysis or chemical analysis. They will tell you what the percentage of each element is in the compound. And that's pretty cool. They don't tell you is what the formula is. Okay. When I was in graduate school doing chemical research for cancer drugs, this was not this particular compound, but I would get these sorts of things back, and then I would figure out the compound, and it would confirm or go against what I was actually doing. So that's what I'm going to have you do on Friday. Okay. And that's why I wanted to record this, is so that you actually get a chance to like see what I have been doing. Okay. So I will actually stop the live stream